Hello. Now we are going to take a look at how to run descriptive statistics in SPSS, and we'll start with the univariate statistics and then we'll look at bivariate statistics. So if you open SPSS, it's a big program. It always takes a little longer to open. And we're going to open File, Compass, Scores, Grades. So I have to look for that here on how to open and where to open. It's the first one. It's the last one that I was using, so it'll be the first one at the top of that list. Select OK. And there's the SPSS output, and there's the data file. So if you recall, when we were looking at our data, trying to understand it, trying to get a sense of what the data is. And if you recall, we have two different variable views down here. We have the data view, which looks like any other spreadsheet, and we have the variable view. It shows you all the variables. So let's take a look at running descriptive statistics. What I want to show you is that output file, output 1, is running behind the SPSS program. So the first thing we want to do, there's a couple of different ways that we can look at descriptive statistics. And recall, descriptive statistics, we're looking at the central tendency, dispersion, and distribution. For central tendency, the mean, the mode, the median, there's a couple of different ways that we can do this. So let's first of all decide which variables we're going to use by looking at how they're measured. So I think we'll take a look at a couple of different variables that are measured on a scale. Maybe the grade in beginning algebra, which is that Math 23, and grade in Math 111, which is intermediate algebra, with this data file. So the first thing we can do, one way to get to this, is through Analyze. Analyze is how we're going to get to all of our statistics that we're going to be running from here on out. So look at Analyze, and you can see we have one option here that just says descriptive statistics. And under that option we have frequencies for frequency distribution. We have just plain old descriptives. We have a way to get to our cross tabulations. And those are the three that we're going to use to look at descriptive statistics. So one way to get to descriptive statistics for these variables that are measured on a scale is just by, or any variable, is just by looking at descriptives. So let's see what that gives us. So under descriptives, you have your variable options on the left-hand side. Let's look at grade in Math 23. Let's look at grade in Math 111. So let's see what options gives us. Let me move that over. So if you select options, you can decide what you want. Mean, sum, standard deviation. You can get your information for the distribution around kurtosis and skewness. You can get the range just by opening that descriptives box. So let's select all of these for now. So we're going to select mean, standard deviation, min, max. Let's select the range, and we're going to select for kurtosis and skewness statistics. This SE mean stands for standard error mean. We're not going to use that right now. And select continue, and then OK. So the output pops up, and let's see what we got. Perfect. Descriptive statistics, it's giving us exactly what we wanted. We can see here that the range in these grades is from 0 to 4.0. And the range is simply the max minus the min, so the range is 4. It gives you how many cases, so the n, how many cases were for each variable. The mean grade in Math 23 is 2.5. The mean grade in Math 111 is 2.6. Gives you the standard deviation, and here's the skewness statistic right here, and the kurtosis statistic for when we are looking at distribution. And if you recall, we said that for skewness, anything less than a negative 0.2 or positive 0.2, or, well, it would be anything larger than a negative 0.2 and then less than a positive 0.2, would be a problem for skewness. Kurtosis, I think the closer you get to 0, same thing, same range on kurtosis. Recall that skewness is is there a data tail at one end of the distribution, and kurtosis was about peakedness or flatness, the opposite of the peakedness. Okay, so that's one way to get this descriptive statistics, but you can see we didn't get to everything. We didn't get to the other two measures of central tendency. We just got to mean, and we got to one measure of dispersion, standard deviation. That other measure of dispersion is range. And we got a couple of measures for our distribution by going that way. Another way to get to some descriptive statistics is by opening up just frequencies. So this is going to give you a frequency distribution so that you can look at how many cases there are in each value of the variable. So let's look at those same two variables. Grade Math 23, grade Math 111. And if you don't select anything on this right-hand side, let's see what you get. Actually, you can select whether or not you'd like to see the frequency tables or not. And when you're looking at a scale variable, sometimes that's not such a bad idea. Let me show you why that is in a second. With grade, we only have a range of 4. So that's one that's easy to look at in a frequency distribution. It's not so long. Let's take a look at what you get. So to get this, I just ran frequencies. Here's the frequency distribution for grade in Math 23. Just shows you how many cases there were in each value of the variable. So 101 students had a grade of 2.5. Same thing in grade in Math 111. Just gives you the frequency of cases at each value of the variable. That's what frequency means. Percent is just the percent of cases. And you can see in this column, in the percent of cases, it's also, the 100% is also taking into consideration missing values. And what that means is that our data file includes 1,556 students. And all this missing means is that 1,300 of them didn't take grade, or didn't take Math 111. I don't have a grade for them. Just pulling out the people that I have the grades for. And that's what percent is giving you, the percent of the total number of cases. Valid percent is accounting for those missing variables. So valid percent is basically eliminating those missing variables and giving you the percent, the proportion that each grade makes up out of those that have that grade. So let's look back up here at Math 23. I mentioned 101 people have a grade of 2.5. Out of the total 1,556, that just represents 6.5%. But if you look at out of only the people that have a grade in Math 23, which is the 509, that 2.5 represents almost 20% of those that have a grade. in Math 23. Cumulative percent simply starts at the first value and adds up these percentages up to 100%. So the 7.7 is just drawing this 7.7 over. The 11.8 is adding 7.7 plus 4.1, drawing it over. So this is one way you could quickly, with the cumulative percent, say, oh, if you look at this 1.5 and below, sometimes we say success in a class is a 2 or above. This is one quick way you could say, well, 20% with this 19.6, 20% were not successful in the class. And then this remaining would be the 80% is successful in the class. That's one way to use cumulative percent. So frequency tables, let's look at why frequency tables in a scale variable that has a ton of values isn't very helpful. Oh, and one thing I wanted to point out is you can run these analysis whether or not you have this output window showing. You can still get to analyze up here, or you can run analyze if you have this main data file window showing. Either way. Oh, same thing if you have this in data view, you can also still run anything you need to run. So regardless of which window is showing with SPSS, you can run your analyses. Let's see what it would look like to run frequency distributions on a variable that we know has a very large range. So if you just press reset, that clears all your values. I believe that ACT, let's look at compass. The compass placement test has a range from 0 to 100. So if I take a look at compass test score on writing and say display frequency tables, you can see why it's not so helpful to show a frequency distribution. Here it is. Here's the frequency distribution for that variable. And it's not as easy to interpret this kind of table. It's better probably to look at descriptive statistics on this in a different way. This ends this part of the module's presentation. Please move on to review the next part